We're gonna win. We're gonna win. We're gonna win. We're gonna win. Today's experiment is about wind. I thought it was wind. Yeah, anyway, we're gonna talk about wind today, but before we do any sort of experiment, we gotta make sure we got all the right materials to do them. And go ahead and grab that bag. Inside of the bag that we're going to be needing for today's experiment is the bag that has 2 cups in it, something that looks like a little tiny pinwheel, and a few other stuff inside of the cup. That's the bag that we need to grab. And also from your envelope, grab these 4 straws and 1 tall one. It looks like a straw as well. We're gonna use that for one of our experiments. And also, aside from that, these are things that are not included. Grab a pair of scissors and 2 cups, 1 that is empty and 1 with some water. All right, so that being said, once you got all of those things, we can get started about talking about wind. So, what is wind? Well, wind is just air that is moving. If it's staying still, it's not really wind. But once the air is moving, that's what we consider as wind. But can you see it? Where'd it go? Yeah, you cannot see it, but you can see what it is moving, right? Like sometimes we would see the wind blowing the leaves and the leaves would just fly and land still on the ground. Or you might see a kite go way up in the sky. It's not just, going off on its own. What's really keeping it up there is the wind. Even though you can't see the wind, you can see the kite that is being carried up by the wind. Also, let's say a sailboat, right? It's moving, right? What's moving that sailboat is also the wind, right? But again, wind is just air that is moving. Try this. Take your hand, put it in front of you, and just move the air. If you move the air, ooh, I can feel it. It feels really nice. That feels really good. Yeah, so whenever you move air, that is wind. And the way we did that was we could fan ourselves by moving the air. But what about the wind outside? Is there a giant monster going, here's some wind, guys? No, actually, what helps us to make that wind is the sun.
How does the sun make the wind?
Great question. Well, first thing I want to let you guys know is that the sun does not go like this. He doesn't go, he doesn't do that. Instead, what happens is the sun is just being itself. And what it does is it heats up everything around it. So if you take a look at our planet Earth here, right, it heats the Earth as well. But guess what? It heats the Earth unevenly. There are parts of the Earth that get a lot of heat. There are parts of the Earth that do not get a lot of heat. Kind of like the North Pole and the South Pole, right? Those parts are usually pretty cold, whereas in the middle, the equator as we call it, right, it's usually a lot more hotter. So again, parts of it get a lot more heat, the other parts don't get as much amount of heat, and so some parts are hot, some parts are cold, and it does the same thing with the air. Some of the air gets really warm, and some of the air doesn't get as warm, okay? And whenever the warm air and the cold air meet together, there's something really interesting that happens, which is what we call convection, where basically the warm air starts to rise. It goes, the warm air rises, and then the cool air sinks. It goes, okay? But notice they're moving, right? Warm air moves, rises, and cold air sinks. It's moving. But remember, whenever air is moving, do you guys remember what that's called? That's just wind, right? So we see that the wind is moving, that convection, through the process of convection, right? The warm air rises, cold air sinks, it's moving, it's creating the wind. So that's how the sun helps. It unevenly heats our planet Earth, okay? So now that we know how wind is made, you know what we're gonna do? We're gonna do our first experiment where we're gonna use wind to move a tiny object. Okay, so for this experiment, these are the very things that we will be needing. Grab inside of your bag the 2 cups. They have holes inside of them. So we need both of these, keep them together. Also, grab the balloon, and the balloon is already tied together like this. It's cut in half. Grab those guys together, and also grab the two little tiny cute little baby cups as well. Okay, so what we're gonna make here is we're going to be making what we call a Vortex Cup. Okay, all we need to do is just take this, what do you call it? Your balloon, and put it right over the top of there. Now let me scoot this here so you guys can see my cup. Doop. Okay, and now this part's a little bit tricky, okay? If you need some help, just ask mom and dad to help you out. But what you wanna do is you wanna open up the hole of the balloon. You see that side, right? And what you wanna do is you wanna put all 4 fingers of one hand in, all 4 fingers of the other hand in, and what you wanna do is you wanna stretch it. You wanna stretch it as far as you can, but then with your thumbs are really what's going to make it stretch upward. That way it really stretches not just this way, but also upward. So you're gonna use your thumbs on the back, stretch it up, and then keep it open, rip it around, and then if you start to let go, you see, it wrapped all the way around our cup. If you didn't get it the first time, don't worry, you could try it again, okay? But once you get it like this with the balloon wrapped all the way around, then you got yourself your own little mini air cannon, because if you pull over here, well, you know what's gonna come out of there? Some air. And whenever air moves, it makes some wind. So this is where we use our little tiny cups. You could take them apart, and you could actually use other little things at home. So maybe find a toy, maybe find something very light, and you can use that to do this experiment. So again, just pull that and then aim it wherever, whatever your object you're trying to aim at is. And right, you don't aim this way because it's gonna go upwards, right? So you're gonna aim this way, and then ta-da! As you can see, it shot right at that. And I still got another one. Just remember, pull it, right? Aim it, and fire! I went all the way over there. So again, with all of these cups, or rather with all of these little tiny things, pretty cool thing that happens with our little Vortex Cup, air cannon, air Zuka, however you want to call it. Okay, but if it ever gets stuck inside like this, okay, all you need to do is just blow through the other side. Ta-da, and the belly button's back out. It's not a belly button, it's just a balloon. But in any case, just again, pull it, aim, fire. I got 2. Oh gosh. Another really cool thing you could do is, instead of just putting the cup right there, what if you put the cup in the hole? Oh, did you see that? So here, watch. So again, all you need to do is just put it inside of the hole, right? Aim and fire. Pretty cool. So, you know, you can have a lot of fun with this little cute little mini air Zuka. So when you think about wind and our discovering how the sun was able to help us make the wind, who found out about this? I mean, you can't even see it. Was it the mailman? Was it the mailman that found out? Nope. Was it the police officer? Nope. You know who it was? Special scientists that we call meteorologists.
What's a meteorologist?
Good question. Meteorologists are, again, these very special scientists that study and predict the weather. So they really specify an understanding about the weather and also about wind. But of course, they're not just running around like, oh, wind, come back, come back. I want to understand you. Talk to me, wind. They don't do that. They use special tools, right? Like this. This is a weather vane, okay? And what it does is it helps us to find out the direction of a wind. Now this here is not really a meteorologist. You see, this Mega Manoa is kind of weird throwing around his sock, but he has the right idea, because you've probably seen this also at the airport. We call those windsocks. You could also call them weather vanes. They basically serve the same purpose again as to telling us as to which direction the wind blows. Here, if you look here, you got letters like N, we got W, S, and E. Remember from our compass experiment, we understood the different directions, north, south, east, and west. But this arrow on top is moved around by the wind. If I blow on it, as you can see, it's moving towards a specific direction, and it could point you as to which direction the air is moving. But what use is that? Is that just to tell us, oh yeah, the wind's going that way? Well, that's actually very important, especially if there's a storm or if there is a fire, right? If there's a storm and the wind is blowing that way, the weather vane is saying, hey, it's going that way, then everybody that is living on that side need to really be careful, especially if there's a fire. It really does help the firefighters. By the way, firefighters, thank you guys so much for always helping us, right? So if the wind is blowing this way, then most likely the fires are going to be carried along by the wind. Everybody living over here needs to be very careful. And again, the firefighters need to realize this and help out everybody accordingly. So again, these weather vanes really do help out in terms of telling us, hey, is it going north? Is it facing towards west, south, east, right? In the different directions. And that's what's really important about these weather vanes. So that's one tool to tell which direction, because remember, just by looking, I can't see the wind. You cannot see the wind. So that's why this is very, very helpful. Another really awesome tool that they use is something called an anemometer. So this anemometer is also pretty cool because, well, can you tell how fast the wind is blowing? No, we can't. But an anemometer can, because if I blow on this, watch what happens. Ready? Look. Depending on how fast I blow or how slow I blow, it's going to start to turn. So by the speed that I blow, by the amount of pressure that I blow, that's how fast or how slow it's going to go. So if I blow really fast, here, let's give it a try. Let's see what happens. Whoa, it's going a lot faster, right? So it either goes really fast if the wind is blowing really fast, or it goes really slow if I blow really slow, right? So that's a really cool tool called the anemometer.
That is so cool.
Yeah, right. Even though you can't see it, these meteorologists use these tools to help us to see the invisible. And you know what? Now we're going to make ourselves an anemometer. Okay, so go ahead and grab yourself the thing that looks like a straw. Okay, and the other part that looks like a flower. Okay, looks like this, and that's all you need to make this anemometer, the pinwheel anemometer. Just take the back of the pinwheel here, and there's a little part that goes right into here. Just go ahead and push that in, and ta-da! All done. Now all you need to do is just blow it, and when you blow it, see? So also this acts just like the anemometer, because depending on how hard or how fast you blow, it's either going to move really fast or really slow. So now let me try to blow really hard and fast like a hurricane, right? Hurricane! But it's not always a hurricane. It could be a nice cool breeze, right? Meaning it's blowing really slowly. So let me blow really slow. Ready? Ooh, nice breeze. Right, so you guys could use this. Maybe you could even walk around with it. As you can see, the more I just move it around, it's going through the air. It's just, already moving around. So maybe go outside, run around for a bit, just watch your anemometer and you could see it moving. Or you could just stay still. Even when you're staying still, probably the wind is blowing towards it and you'll see it still moving because the wind is going to blow on it. All right, so have fun with your anemometer. Now, something we don't usually think about is that air actually has a weight. It really does. It really does. And you don't usually notice it is because you're always inside. You gotta go out, get out, run around, do something, because if you run around outside, you could feel the air blowing on you, okay? So you'll notice a lot more when you're outside. Even when you're inside of a car, if you roll down the windows, you stick your hand out, it's gonna blow your hand, right? That shows you that there's the air there, and it's all around us. It's everywhere. You can't hide from it. It even goes miles up into the sky, right up into outer space. way up there. It's everywhere, and it's pushing down all around us. It's not just only pushing on my head, it's pushing on my face, it's pushing on my shoulders, it's pushing my belly. It's pushing everywhere. Okay, and that's why you don't really feel it too much, because it's evenly spread all over our bodies, and that force of all of this air pushing down on us is what we call air pressure.
What is air pressure?
Well, air pressure is, again, just that force of air pushing down on us. Again, not just on one spot. Where is it? Is it only on my nose? Nope. It's everywhere, all over our bodies. And you know what? We're going to use that air pressure, and you're going to be able to see it with our next experiment, where we're going to use it to move some water. So for this last experiment, these are the things that we'll be needing. Go ahead and grab yourselves your 4 straws, the little bendy boy straws. Grab those, and also from the bag, grab your tape and the pair of scissors and the 2 cups that we had, one with water and one that is empty. So the first thing we want to do is we basically want to take these straws and piece them together. We're going to do something called siphoning, okay? Where basically we're going to use air pressure to move some water from one side to the other, okay? So take these straws. Now, if you notice, there's a little bendable part right on the top of the shorter end. There's a little cut part. This straw is already cut into a little piece because we want to piece that together with the other bendable straw. So we want to take the short one and attach it to another piece that is long. You see it's nice and long, this one's nice and short. So just kind of squeeze this together so it would fit nice and snug into there, and really kind of push it all the way in. And once you pushed it all the way in, then what we want to do is we want to tape that right onto there. Try your best not to have any sort of crack in this little part where we pushed it in. So with your tape, let's actually already cut this into 4 pieces, okay? So I'm going to cut it in half. Once you cut it in half, then just cut whatever you've cut also in half, making it into 4. Technically we need just 3, but anyway, let's just cut it into 4. Then go ahead and again take your tape, and we're going to wrap it right around our straw. There's my tape, and we're going to put it right around the straw there. Remember, just try to make sure you pushed it in all the way, and just wrap that tape right around the crease of where they are meeting together. See? Then we just want to do the same thing with the next ones, right? Get the short one, stick it into the long part, right? The long piece, squeeze it together, push it in. There's number 2. Get the tape, take the tape off. We're gonna put the tape right at the crease there. Now, just in case your straw is not cut where the short part is, just make sure you put the cut part into the part that's not cut. So in this case, all of my straws were cut correctly, but in case yours was not cut correctly, make sure you put the cut part, which is this one, the short one, or in case you have it, the long one, make sure you put the cut part into the part that's not cut of the other straw, okay? So here's my last piece. We're just gonna push this one, squeeze it together, just like that, and push it in. There's that. And we're gonna put our final tape right into there. Remember, just keep it nice and close, right? And then just take your tape, wrap it around, and there you go. So now that we got this, let's get our cups. So now that we've got our cups here, make sure that one of the cups, or specifically the cup of water, is higher than the empty cup, okay? So then go ahead and take your straws, okay? Put one in one and one in the other. And what we're gonna do is we're gonna move the water from in here to over here. But we're gonna get it started, and the rest is gonna be air pressure pushing it down, okay? Because remember, inside of this cup of water, do you remember what the air is doing? The air's not just sitting there doing nothing, it's pushing down on it evenly all around. And we're gonna use that air pressure as a force to push all of the water all the way down to over here. So here we go. Once this is up there, then all you need to do is just take the other side and suck on it until the water starts running, and then just leave it there, and you got yourself your siphoning tube. Here we go. So I'm gonna suck on it. Ready? Ta-da! And then you could just leave it inside, or you could just watch it pour. But again, what's really going on here is the water over here is being pushed, not by me, but by the air pressure. Okay, so it's being pushed by the air pressure, and you can see it's coming. Let's just keep on going. Let's keep on going. Let's keep it on going because of the air pressure. Okay, that's really what's going on here. And then we just wait until it goes all the way. And there you go. You can see again, we got some water that came from over here and went into our second cup here. And you can even see we finished the whole entire thing. Ta-da! And guess what you could do? You could do it again, right? Just take the cup with the water, right? I'll just get the rest of that, put it back on top, put the empty cup on the bottom, do it again, stick it in, right? Just suck on it and let it flow all the way inside, and you're gonna see just this water going straight from here. But remember, what's pushing it? Is it me? Is it you? Is it mama? No, it is the air pressure pushing down on this all the way from one side to the other. There you go. It sucked it all the way to the other side. And again, what really did it was the air pressure that is all around us, right? So we talked all about air and wind and how that all happens, right? So I hope you guys all had a lot of fun here with Mega Manoa, and until next time, I'll see you at home. Bye! Just want to give a big thank you to our guest scientist for today. Thank you, you did such a great job. And if you guys want to be a guest scientist, just shoot us an email and we'll see what we can do about getting you on the show with Mega Manoa. Ooh. Yeah, so just shoot us an email and then we'll see you soon.